Welcome to all my dear students. I am Saroj Kumar Sethi, lecturer in chemistry of Nalanda Vidya Mandir Plus 2 Science College. So, in my previous lecture, I have discussed about that is conductance, specific conductance, and molar conductance, and the problems related to them, along with some important concept, that is variation of conductance with respect to dilutions, variation of molar conductivity and equivalent conductivity with respect to their dilutions, along with Kovalev's law. So these topics we have already discussed in our previous classes. So on this class I am going to discuss that is galvanic cell and the difference between electrolytic cell and electrochemical cell, and some other cell reactions which comes under galvanic cells. Example, that is Daniel cells. In our topic, in our class, we are going to discuss that is electrochemical cell, electrochemical cell, galvanic cell, Daniel cell, then next one, that is difference between electrolytic and electrochemical cell. Electrochemical cell. See, in previous classes we have already discussed that is electrochemical cell. What does it mean? Electrochemical cell. Electrochemical cell means it is the interconversion in between chemical energy and electrical energy, or we can say that the interconversion of chemical energy to electrical energy and electrical energy to chemical energy. This concept, it shows the electrochemical cell. So under this, a galvanic cell is coming. Galvanic cell means it is only the interconversion, that is conversion of chemical energy into electrical energy, or we can say the spontaneous cell reaction, spontaneous redox reaction which convert into electrical energy. From chemical energy converts into electrical energy. So galvanic cell means the spontaneous redox reactions produced from that chemical energy or the that cell, it converts into electrical energy. That is galvanic cell. That is the chemical energy converts into electrical energy. So this chemical energy, where it comes from? It comes from spontaneous redox reaction. spontaneous redox reactions from cell. Under the electrochemical cell, two types of cells are coming, that is galvanic cell. It means this from the chemical energy it convert electrical energy. Another one is that is electrolytic cell. So this electrochemical cell is of two types, that is galvanic cell and another one is electrolytic cell. So here galvanic cell means chemical energy converts electrical energy. Here electrolytic cell means electrical energy it converts into chemical energy. Now we are going to discuss that is galvanic cell. Galvanic cells, it is one type of cell from the electrochemical cell that it converts chemical energy which produced from that spontaneous redox reaction converts into electrical energy. So one of the most renowned galvanic cell we are going to use, most of the time we are using that one, that is, so most of the time in long questions it asks in board exam, that is galvanic cells, and it talks about that is construction, working, then conclusion along with the use of salt bridge. So first one, if I talk about construction, first we need to take two half cells. This is two beaker, and here a zinc rod is placed, here a copper rod is placed. This the beaker one, here it is the beaker one, it is beaker 2. So in beaker 1, in container 1 and container 2, it present zinc sulfate solution. Here copper sulfate solution is there. If zinc rod is dipped in zinc sulfate solution, it is zinc rod. And similarly, copper rod is dipped inside the copper sulfate solution. These two electrodes are connected to an electrical appliance, that can be electrical bulb, or galvanometer, which detect the electric current. It may be galvanometer, it may be electrical bulb, and here a salt bridge is used. That salt bridge is double bend in 90 degree and it connected to both the cells. So this is construction. So here what we have to write, 0.1 molar zinc sulfate and copper sulfate solutions were taken. In two different container, two different vessels. Second one, zinc and copper rods were dipped. Zinc and copper electrode electrodes were dipped in their respective solution, respective salt solution, and two electrodes were connected to galvanometer or electrical bulb. We can write two electrodes, that is copper and zinc, were connected to galvanometer to detect the current, to detect galvanometer or electric bulb to detect the current. Salt bridge is being used. Agar solution, potassium nitrate, potassium chloride solution contains salt bridge is connected to half cells, is connected to two half cells, So these are the four important points which we need to write in construction. Most of time these questions it often asked in board exam. For long question it carries 7 marks, and in construction part we need to write these four important points. First, two different beakers were taken. 0.1 molar zinc sulfate solution and copper sulfate solutions were taken to them, and zinc rod and copper rods were dipped into their respective salt solution. Then these two electrodes, zinc and copper, are connected to galvanometer or an electrical bulb to detect the current. Then agar solution, potassium nitrate solution and potassium chloride solutions were taken in salt bridge, which is bent type U-type shape, U-shaped tube, which connect two half cells. So these are considered as a half cells. This is a half cell and this is a other half cells. So two half cells is connected by U-type salt bridge. This is known as salt bridge. This is salt bridge. This is salt bridge which contain agar solution and a potassium chloride, potassium nitrate solution is present. These are all about construction. Then next we need to focus on its working, or we can say its functions. See, this is zinc rod. So what would be the function? First one, the interface in between, or we can say the interaction between zinc sulfate and zinc electrodes are in such a way that this zinc electrode, it loses two electrons. So the zinc electrode that is in solid state, solid form, that electrode it loses two electrons. Then what would be the state of zinc? That will be zinc 2 plus in aqueous solution. Because this zinc rod, it will try to have a positive charge, because anode, this is the anode which having positive charge, and this is negative charge, and this is cathode, it is positive charge. So try to remember this one. In galvanic cell, anode is negative and cathode is positive, but it is totally opposite to electrolytic cell. In electrolytic cell, the cathode will be negative and anode will be positive. So in galvanic cell, anode is showing negative charge and cathode is positive charge. In anode, it shows oxidation. That's why in anode, that is zinc rod, it loses 2 electron along with zinc 2 plus ion. So this zinc rod, it loses 2 electron, and this 2 electron will move from that is anode to cathode. In galvanic cell, electrons are moving from anode to cathode, and the zinc rod, by losing 2 electrons, the zinc 2 plus ions is dissolved in zinc sulfate solutions, which present inside the beaker. So this is the zinc electrode which occurred at a anode. Similarly, at cathode, when the copper sulfate and copper electrodes are getting interaction with each other, on that time the copper sulfate, it splits into copper 2 plus ion and sulfate 2 minus ion. So here the copper 2 plus ion from the copper sulfate solutions will deposited over the copper electrode, and the electrons which is released by the zinc electrode is accepted by copper 2 plus ion over that copper electrode. So at cathode, that is at copper electrode, the copper 2 plus ions which is released from the copper sulfate solution, that copper 2 plus ion is deposited over that copper rod, and it accepts 2 electrons which is released by anode. So by accepting 2 electron for copper 2 plus, it will changes to copper solid, or you can say here the copper deposition is occur. It is reduction. It is reduction reaction. So what you learn from the function part? In zinc electrode, the zinc sulfate solutions, the zinc 2 plus ions, it increases because this electrode is a negative charge. So when the zinc electrode, it is a negative in charge, it try to have a positive charge to neutralize its charge. Because zinc electrode is a negative, because it is an anode, it try to have positive. How? By losing 2 electrons. So zinc, its original charge is positive, that is negative, anode is negative, it try to have a positive charge to balance the negative and a positive to become the neutrality. That's why zinc, it by losing 2 electrons to have zinc 2 plus ions, as the zinc rod is negative, with having that zinc 2 plus ion, that is a positive, negative, it neutralizes to each other to have a in neutral state. That's why this reaction is showing, that is oxidation is showing in anode. But in case of cathode, when from the copper sulfate solutions, copper 2 plus ions is deposited over the electrode, then on the copper rod, copper 2 plus ions deposited means excess number of positive charge is there. To neutralize that positive charge, 2 electrons from that zinc rod, it will accept, and by having 2 electrons to the copper 2 plus ion, it will neutralize to form copper solid. So previously it was positive charge over the electrode, copper electrode. By accepting 2 electrons, 2 positive, 2 negative, it neutralizes to each other to have a copper solid. it is deposited upon the copper electrode. And similarly, zinc is a negative charge in nature. So when zinc loses two electrons, it will be positive. So negative, positive neutralize to each other. And one thing we need to know that electron is moving from, that is from anode to cathode. Electron is moving from anode to cathode. So its opposite direction, that is from cathode to anode, electric current will pass. So when that electric bulb is glow, or we can say when the galvanometer, it will show deflection, on that spot we will get to know that electric current is passing. So from that spontaneous chemical reaction, that is oxidation at anode and reduction at cathode, from the spontaneous redox reaction, electrical energy it develop, or electrical energy it generated from that spontaneous chemical redox reaction. This is the concept of galvanic cell. This is the function part. Whatever I discussed here, that is comes under, that is the function or working. Then what is the use of this salt bridge? Salt bridge, it is a U-type, U-shaped tube. It is U-shaped tube. It contains potassium nitrate, potassium chloride and agar solution. Potassium nitrate, potassium chloride and agar solutions. It connect to both cell. It is connected to both half cell to maintain neutrality between them. To maintain neutrality between them. To maintain neutrality between them. Next one, it complete the circuit. Another main use of salt bridge, it complete the circuit. It complete the circuit. So these are few characteristics being shown by salt bridge. The main characteristics is, the main use of salt bridge is, it is connected to both the half cells to maintain the neutrality between them, and it completes the circuit. Here, if the excess of positive ion is there in one of the half cell, then it will try to neutralize with having some negative charge. Similarly, so it also completes the circuit. So this is the use of salt bridge, and it is the galvanic cells. So it is very long question. It is very important questions for a long question, so which has been asked in board exam, which carries 7 marks. So you need to understand very properly. And one of the galvanic cell is, that is Daniell cells. Daniell cells also containing, that is zinc and copper electrode with their respective solutions, but little bit difference in their, that is structural modifications. One structural modification is present in Daniell cell, but concept is the same. So this is all about the galvanic cell. Then next move on to Daniell cell. a little bit structural modification is present in Daniel cells. Daniel cell is like it is the zinc copper sulfate solution galvanic cell. Here it is different. It is different from galvanic cell is that in place of salt bridge porous port is used. Porous port is being used. It has been used. Porous port. The role is same. The role of porous port is having same role along with that is just from the salt bridge. Role is same, but structural modification is there somehow. So that is Daniel cells, and its modification, structural modifications will be: this is the container. This is the container. It is the copper vessel, and here it is the porous medium is there, porous port, and inside that copper vessels, copper sulfate solutions is there. Copper sulfate solution is there. Then inside that porous port, zinc electrode is present. Zinc electrode. A zinc rod. It is copper vessels which act as a copper electrode. Inside the copper sulfate solution is there. It is aqueous solutions. And inside that porous port, zinc sulfate solution is present. Zinc sulfate aqueous solution is present, and this copper it act as a positive charge. It is positive charge. It is act as a negative charge. And this is connected with the galvanometer, which detects the current, and this is the structural modification of Daniel cell, and the rest of all the things were remains same as like of galvanic cell. Its functions, its working, that is same. Function is same. In zinc rod, at anode, that is zinc loses 2 electron. Zinc present in solid, that is electrode. It loses 2 electrons to have zinc 2 plus ion in aqueous medium plus 2 electron, that is oxidation. Here it is showing oxidation. Similarly, that copper port, copper vessel, it accepts 2 electron from the copper sulfate solutions. Copper 2 plus ion is deposited over the copper vessels, that inner side. The copper 2 plus ions with having 2 electrons, it will have copper solid. This is the reactions can be seen at a cathode. So for the Daniel cell and galvanic cell, which I have discussed few minutes earlier, the cell representation it will be same. Cell representation for galvanic cell is that is zinc electrode. By losing 2 plus electron, it will reach zinc 2 plus ion with having salt bridge in between them. Then at cathode, copper 2 plus ion with having 2 electron, it will reach to copper solid. So this is the cell representation of a galvanic cell and Daniell cell. There is a much similarity in between them. The only difference is that in galvanic cell, in place of a salt bridge, here a porous medium, a porous port is used. This is the porous port. This porous port means having small pores which connect to half cells. This is the lower one. It is the half cell of copper metal in copper sulfate, that is copper vessel, and that inner side, that is a zinc rod which dip inside the zinc sulfate solution. These are two half cell, and this two half cell which is connected by this porous port that act as a salt bridge. So in Daniell cell, salt bridge is present. In galvanic cell, salt bridge is present. In Daniell cell, in place of salt bridge, porous port is being used. Porous port, which is the alternative to salt bridge. But both the cell reaction, or we can say the cell representation, will be zinc to zinc 2 plus ion, that is salt bridge. This is salt bridge. The cell representation for galvanic cell, it will be zinc to zinc 2 plus ion, salt bridge, which neutralizes these both half cells. Then copper 2 plus ion, it convert into copper. So these are all about Daniell cell. Then we may remember some other galvanic cells, that is copper silver nitride cell and zinc silver nitride cell. And what will be the cell reactions in them? Let's see. Some other cell reactions which is being came from, that is galvanic cells. First one, cell reaction and cell representation. Cell representation. First one, in copper silver nitride cell, copper silver nitride cell means here the copper rod is present in copper nitride solution and silver electrode is present silver nitride solutions. So here that highly reactive metal, that is copper rod. The high reactive metals, it will shows oxidation and it is being considered as a anode. So copper, it will show oxidation with losing 2 electron. So copper loses 2 electron with having copper 2 plus along with 2 electron here, and this reaction will occur at anode. Similarly at cathode, silver, it will accept 2 electron. So 2 silver plus with accepting 2 electron, it will have 2 silver. So what will be the net reaction? That net reaction will be by cancel out the 2 electron from the both the side. It will have copper plus 2 silver plus give rises to copper 2 plus 2 silver. So cell representation will be it will be, that is copper 2 plus, that is salt bridge, then silver plus 2 silver. Similarly we can take other cell reaction, that is that is zinc to silver nitrate solution, zinc to silver nitrate solution, that is cell, zinc to silver nitrate cell. So here also that zinc rod dipped in zinc sulfate solution and silver rod in zinc nitrate solution. Similarly, silver rod is present in silver nitrate solution. So in these two electrodes, zinc and silver, which is more reactive? That is silver. So at anode, zinc will have oxidation reaction with losing 2 electron, then it will be zinc 2 plus 2 electron. Oxidation will occur at a highly reactive metal. Similarly, at cathode, silver ion with accepting 2 electron, it will give silver solid. It is reduction. It is present in aqueous condition. By adding of these two half cell, we will have zinc plus 2 Ag plus. By cancel out 2 electron from both the side, it will have zinc 2 plus ion plus 2 silver. So cell representation will be that is zinc 2 plus salt bridge silver plus silver. This is cell representation for the zinc silver nitrate cell. Another cell, that is nickel copper nitrate cell. Nickel copper nitrate cell. So now tell me, what will be the cell representation? The cell representation at anode, which one will be source anode? The highly reactive metal from the copper and nickel. So nickel is the highly reactive metal. So at anode, nickel will lose 2 electrons. And that is oxidation will show at anode. Similarly, at cathode, copper 2 plus ion accepting 2 electron, it will have copper solid. It is reduction. So the net cell reaction will be nickel solid to nickel 2 plus salt bridge, then copper 2 plus in aqueous condition to copper solid. This is cell representation. If I write the cell reaction, sorry, I have written cell representation. If I write the cell reaction, then it will be nickel plus copper 2 plus ion give rises to nickel 2 plus copper solid. If I talk about the cell representation, then what would be the cell representation? Nickel to nickel 2 plus salt bridge, then copper 2 plus 2 copper. This is the cell representation for nickel copper nitrate cell. Then move on to the next part, that is the difference between electrolytic cell and electrochemical cell. Electrolytic cell. In our the first lecture, the concept which is electrolysis. So that is the came from that electrolytic cell. It is the conversion of electrical energy to chemical energy. Means electrolytic cell is a non-spontaneous cell reactions. By using that electricity to bring back the non-spontaneous cell reaction to spontaneous cell reactions. That is electrolytic cell. In the first lecture we have discussed the concept of electrolytic cell, and on this lecture we have already discussed that is galvanic cell, that is electrochemical cell, the galvanic cell. Now we are going to differentiate between these two. Difference between electrolytic cell and electrochemical cell. The first one, the concept it tells about, that is conversion of, first point, that is conversion of electrical energy converts chemical energy. But in case of electrochemical cell, chemical energy converts electrical energy. Next point, single cell is being used. Single cell is used. Single cell. For example, that is copper sulfate solutions. Copper electrode is dipped inside the copper sulfate solutions. Here it is the single half cell. Single cell is used. Here two half cell. It is the combination of two half cell. One is cathode and another is anode. Single cell is used in single electrode. It is single electrode. But the two half cell, it contain in maybe single electrode, maybe different electrodes. Different electrodes. Example, that is galvanic cell. Here in case of galvanic cell, copper electrode is deep inside the copper sulfate solution, and zinc electrode is deep inside the zinc sulfate solutions. But in case of electrolytic cell, only copper electrode is deep inside the copper sulfate solutions. It present only single cell, that is only one half cell is present. But in case of electrochemical cell, two half cell is present, and salt bridge is connected to two half cell. So here we can say there is no use of salt bridge. No use of salt bridge. Salt bridge is required. Salt bridge is required. Salt bridge is required. It is non-spontaneous cell reaction. It shows it present non-spontaneous cell reaction and it contain spontaneous cell reaction. Spontaneous cell reactions. Here in electrolytic cell, now I have discussed that is in electrochemical cell, anode is negative and cathode is positive. Anode is negative and cathode is positive. That is in electrochemical cell. But in case of electrolytic cell, anode is positive and cathode is negative. So these are all about difference between electrolytic cell and electrochemical cell. Once again I am going to make you remember this few points. In electrolytic cell, electrical energy converts chemical energy. In these cells, the electrical energy converts to chemical energy. Here in electrochemical cell, chemical energy converts into electrical energy. Single cell is used in single electrode. It is combination of two half cells containing in different electrodes. Different electrodes are present in different electrolytic cells. No use of salt bridge. Salt bridge is required. It present non-spontaneous cell reaction. It containing spontaneous cell reaction. Here the anode is positive, cathode is negative. But in case of electrochemical cell, cathode is positive and that anode is negative. So these are the difference between electrolytic cell and electrochemical cell. So for this lecture this much only. On our next lecture we will discuss electrode potential, standard electrode potential, standard hydrogen electrode potential, EM of cell. Okay, for this lecture this much only.